In the last AP review video, we made regular chocolate chip cookies. But I found a similar recipe on sallysbakingaddiction.com for giant chocolate chip cookies. And when I say giant, like I made the cookies and still when I opened the oven, I couldn't believe how giant they were. Like too giant maybe? We're going to compare the small cookies to the big cookies in what your teacher in AP Stats might call combining random variables. And if you've been combining random variables in class for a while, but you still don't get it,
at this point I'm too afraid to ask.
Don't worry, I got you covered. Okay, these giant chocolate chip cookies take significantly longer to bake. I shouldn't say significantly in a statistics video. They take way longer. Like 20 to 25 minutes per batch instead of 10 to 12. It's like twice as long. The mean amount of baking time for these cookies is 22 minutes, standard deviation 1.5. So here I have the mean and standard deviation for these giant cookies, and then I have the mean and standard deviation for the regular cookies from the last video. As you can see, significantly, oh, I did it again. As you can see, a lot less time. I had to think about it. I'm gonna try it again.
Oh, come on! What is wrong with me today?
As you can see, a lot less time and also a little bit less variable. The standard deviation is a little bit smaller. Now, if I want to compare these two cookies, what I can do is subtract to find the difference between the bake times for the two kinds of cookies. So we could take the giant mean and subtract the regular mean, and that would give us the difference in times. So 22 minus 11.6, that's 10.4. That's the difference in bake times between the two batches. So if you threw in a small batch of cookies and then took them out, you would have to wait another 10.4 minutes for the giant cookies to be done. Now, when it comes to standard deviations, one does not simply subtract standard deviations. I have an entire video explaining why that is. I will link it. I still don't know. One of these sides, I don't know. That video goes into more detail of why this is, but if you're just watching this video to get the basics, when you're combining two variables, whether you're adding or subtracting, this is what you always do with the standard deviations. You're always going to add the variances. So you take the standard deviations, you square them both, you add them together, and then you take the square root. Whether you're adding the two variables or subtracting the two variables, this is always what you do. So here our standard deviation is 1.86. So there's a bit more variability here when we're looking at big cookie minus small cookie. Okay, so let's say we're asked, what's the probability that the difference in bake times is more than 10 minutes? Well, the mean of this distribution is 10.4. So 10 would be pretty close to 10.4. Like, I don't know if that's even close enough. It's going to be really close to 10.4. More than 10 minutes would be to the right. We want to find this area over here. So we're going to use norm CDF. Lower is going to be 10, upper is going to be a large number. I'm going to do 10,000. For the mean, we're going to put in 10.4, and for the standard deviation, we're going to put in 1.86. So second vars norm CDF, we'll hit paste, we'll hit enter. 58.5%. All right, that makes a ton of sense. I was expecting something bigger than 50 because this was more than half the distribution, and it's not that much more than 50, just a little bit. So odds are pretty good that the difference in bake times is going to be more than 10 minutes. If you're taking the AP test, be on the lookout for questions like this, where they give you two different distributions of something really similar, like sweet potatoes grown on a local farm versus an international farm. In this case, they tell you that both of these variables are normal. They give you a mean and standard deviation for the local farm and the mean and standard deviation for the international farm. Now this question says, what's the probability that a randomly selected international potato weighs more than a randomly selected local potato? So I'm going to think of this using the variables I and L. They want to know the probability that an international potato weighs more than a local potato. Now what I want to do is rearrange this so that I can write either I minus L or L minus I. I think I'm just going to subtract L from both sides of this inequality. Okay, and I think this makes sense because we're trying to find the probability that the international potato's weight minus the local potato's weight is greater than 0 or positive. That would mean that the international potato weighs more. So I'm just going to make up a new variable called D for difference, and we'll let D be international minus local. Okay, so the mean of D would just be international mean minus local mean, so that's 0.2. And then standard deviation, once again, one does not simply subtract standard deviations. You're going to square both standard deviations, add them together, and then take the square root. 0.58 is our standard deviation of the difference. So now I can picture this distribution is centered at 0.2. I'm trying to find the probability that the difference is bigger than 0. One standard deviation below. Oh, I accidentally made this problem really similar to the last one. I'm going with it. I don't have time to re-record this. Here's 0. We want the area to the right. So we're going to go to norm CDF. Lower, we're going to put in 0. Upper, a very big number. Mean 0.2. Standard deviation 0.58. My camera battery is dying. Okay, 0.63 or 63%. There is a very good chance that the international potato weighs more, and looking at the means, that makes sense. The international potatoes are centered higher than the local potatoes. They're generally heavier. The more practice you do with these, the easier it'll be to identify, like, oh, this is one where I'm going to be combining two variables. All right, if you have any other questions that you're too afraid to ask, please leave them in the comments. I would love to answer more. Hit that subscribe button so you don't miss any AP review content coming your way.